Interface. Interface is an abstract data type. It has no direct implementation. An interface contains method definitions. Usually, the interface is used as a contract. Interface implementation. Any data type that corresponds to an interface contract is automatically considered to belong to that interface. So we don't need to implement the interface manually. This is somewhat different from other programming languages, where when creating an interface, we have to explicitly state which interface we will use. Firstly, we create an employee interface that contains the printName method. Subsequently, we define a truck-named attribute, within which we have two attributes, id of type integer and username of type string. Following that, we proceed to implement the printName method of the employee interface. The implementation prints the employee's ID and username along with a generic employee name. Next, we declare a variable E1 as an instance of the employee interface. We initialize its attributes with specific values for ID and username. Finally, we invoke the printName method through the interface, resulting in the display of employee details. Now it's time for us to print to see the results. Blank interface. Golang is not an object-oriented programming language. Usually in object-oriented programming, there is one parent data at the top which can be considered as all the data implementations in the programming language. An example in Java is Java lang object. To handle cases like this, in Golang, we can use an empty interface. An empty interface is an interface that does not have a single method declaration. This means that all data types will automatically be implemented. The interface is empty. It also has a type alias called any. In this illustration, we delve into the concept of empty interfaces in the Go programming language. Let's consider a function named ups that returns an empty interface. The primary characteristic of an empty interface is its ability to encapsulate values of different types. Initially, let's set the return value of ups to an integer, representing a simple use case. In practice, the ups function could be designed to perform various operations or computations. Upon calling the ups function within the main function and storing the result in a variable named empty, we witness the dynamic nature of the empty interface. The ability to print and work with a value of any type, in this case, an integer, showcases the power of the empty interface. Now, let's explore further by altering the return type of the ups function to a string. Continuing this exploration, we modify the return type once again, this time to a Boolean. Despite this change, the function remains consistent in its ability to return values of various types. This exemplifies the abstraction provided by the empty interface, allowing for generic and adaptable code.